Hi, welcome to DSA for FAANG. So today we're gonna study the father of DSA, father of data structure topic, that is recursion. If you will miss this topic, then binary tree, the most important FAANG interview target topic, binary tree, will gonna miss out. Everything gonna miss out. And leave if you'll miss this topic, then leave the dream to get into a FAANG company. Facebook, Amazon, Google, Microsoft, Netflix. No. Recursion is the father, recursion is the base of all the topics. Okay, and I know this topic will not easily digest in one go. That's why I'm not gonna directly jump into the code. I'll give you the real world examples. Real world example is the best way to get the concept clearly. Okay, just focus. Okay, fine. Consider this is you. Consider this is you. And here is a ball. Now I have given you a task. Just listen carefully. Keep everything shut down. Your phone, everything else. Stay away from them. This is you and here is a ball. Here is a ball B. Okay, ball. Now I have given you a task. Place A, place B. Okay, here is another person standing, that is P. Now I have given you a task that take this ball, handle this ball to person P. Simple. Take this ball, handle this person to P. Okay, so you'll be thinking like, okay, it's very easy. But the twist is, what is the twist is, you can't go directly from A to B. You can only go from A to A1. A1 is another place. A is a place. I have given you a task that there is a place A where you are standing. So from A to B. Okay, B is another place where P is standing. Take this ball, handle this ball to person P, which is standing on at the place B. Okay, but you can't go to B. Like, you don't know direct path to go to B. But yeah, you can go to A to A1. A1 is another path between A and B. Another place. So okay, you use your brain and you just take this ball to A to A1. Now you find out that okay, at A1 a friend is staying. Your friend is staying. Let's handle this ball to my friend so he will take to B, because I don't know from A1 where I should have to go to reach to B. Simple. Okay, friend came. So this is your friend. You have handled this ball to your friend. Okay, fine. So you have told that okay, take this ball and handle this ball to person P. Your friend told that okay, I can't go directly to B. I don't know the path. But yeah, I can go to some place A2, which is between A1 and B. Okay, then you have taken the ball and you went here. And you call another friend which is living at A2. Okay, and you handle this ball, same thing, to person A2 and tell him that okay, told him that take this ball and give it to the person standing at B, place B. Now this person also don't know directly path to B. So this person told you that okay, I don't know direct path, but yeah, I can take this ball to some place A3. Okay, this person take this ball and came here. Now this person also contacted one of the friend which is living at A3. And this person came which is living at A3. You handle him the ball and tell him that okay, this is the ball. Your task is take this ball and give it to the person standing at place B. Okay, fine. Now he told that I also don't know, but yeah, I can reach to some place A4. Same thing, he came here. Okay, and then he has given this ball to some other person. Okay, other friend, and he has taken the ball and came to B. Okay, the ball has been reached to place B. But you are waiting. waiting stack. The best example I have taken you. Okay, just wait. You are waiting for what? Response. Okay, if you'll understand this example, complete recursion cleared. Complete recursion. I'm telling you, the most hardest, where many of the, almost all of the candidates face difficulties, and you'll be get the clear-cut concept in just one example. Okay, so you are waiting this, and I'll explain you using the stack. And there's a property of stack. When function is not over, function is still waiting. Function is still waiting. Function is still waiting. Okay, function is still waiting. Okay, fine. So you are waiting for response. Response from P that yeah, ball has been reached. So this person has given the ball, and the person P given you a message that okay, ball has been reached. So the person, okay, he has this is the person, he informed this, the message, ball has been reached. He informed this person, ball has been reached. He informed this, ball has been reached. He informed this person, ball has been reached. And he informed this person, ball has been reached. Now this person, you, is free. Okay, before getting the message, you are still in the active state. Okay, that you are thinking like ball has been reached or not, or I have to go to check. What I do is like you are in the tense mode. Like I have the task to do, but the ball has been reached because message is not came yet. When the message came, then you are free. Okay, now I am free because ball has been reached because message came. So when the message is coming, suppose the message came here, so this person got free. Okay, now he had delivered the message that ball has been reached. This person got free. So one by one, all the persons are getting free, and at the end, this person get free. Person is methods, functions, and the process is stack, and complete process is known as recursion. Yes. Now if you'll get a clear-cut understanding of this concept, then please comment down. Comment down how you are feeling. Okay, because we're gonna do a amazing recursion problems. Recursion of in arrays, subset, subsequence, AVLs, segment, binary tree, everything. We'll master. Fine. So I hope you get a clear-cut understanding. Okay. Now let's move little bit to the coding. No, I'm not gonna scare you. Just a basic 1 + 1 = 2, like basic mathematics. I have given you a task that you have to print a number which I'll give it to you. Suppose I have given you number 5. Now you might be thinking like, okay, it's very easy. I'll write the print statement SOP system.out.print and the number num 5 times SOP and 5 times got printed. Smart. No, you can't do. You can't write the print statement 5 times. Only one time you can. Only one time. Whatever you need to write, only one time you have to write. Now you use your brain, and then you come up with a solution. What is the solution? The solution is, okay, I'll declare a method print. Fine, print 1, and it is taking the number. Okay, and inside SOP number, and in the main method I'm calling print. Fine, I'm calling print number 5 times, print num. So you are calling the method 5 times, and here is a method present. So if you're calling the 5 times, then 5 times 5 got printed. Done. Now I told you that you'll call or SOP only one time in the main method, only one time. Okay, again you come up with a solution. Fine, I'm also ready for that. The solution is, you are calling the print only one time, and you are calling the 5 times, you will create 5 different methods. What is the method? Suppose the method is print. Okay, print, and it is taking the number SOP number, and in the method only you are calling another method print2, which is again taking the number, this number print2. Okay, you are SOP, you are displaying, and inside it only again you are calling print3. Similarly, print3 is calling, inside print2 only you are calling print3. So here is a print3 which is also taking the number, and inside SOP you are displaying, and inside it you are calling print4. Similarly, print5. Now can you relate this example with this example? Calling, 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 calling. Getting it? Okay. You are calling print only one time. Okay, so you'll call the print method, go to the print method, SOP, and after SOP it is calling another method. Okay, which is also taking similar, all the methods are similar, just a name is different. Print, print1, print2, print3, print4, print5, taking the same argument int. First you call the print 5, print and taking 5, gone to the print argument 5, SOP 5 got printed, and again, and just before finishing calling this method print2, SOP printed, and then calling means another method, another till print got that 5 got printed 5 times. So you have written 5 methods. Smart. Now if I'll tell you that you need to print 1000 times, then will you create 1000 methods? The problem arises. Will you create 1000 methods or not? Comment down that I will not create 1000 methods. Okay, no, don't comment down. So this is what? Okay, fine. Another thing, when the print, when you call, so this is the solution, when you call print 5, so print 5, it will call the print method, and then in the print method before finishing it, it is calling print 2. So till print 2 got finished, will print 5 got executed? No, all the function is in the running state till you got the response. Familiar? Relate this example. I'm telling you, this is the best example, best example. Fine. So what you have done here, you have found out as identical person which is identical to you, which helps doing the task, which helps the doing your task, and then giving back to your response. You have find out, suppose a task is given to you, okay, but you can't do the task alone, so you have found out the same person identical to you, okay, and which helps us, like you have given the task to your identical person 1, okay, identical person 1, I1, then I1 given the same task to I2, I2 to I3, I3 to I4, I4 done, then the response from I4 to I3, I2 and I1. The task is divided in 5 different methods. Okay, now the final chapter of recursion, that is, these are not identical persons. If I tell you that this is you, one person, okay, you can see you are calling print is calling print2. Now see the print2. Okay, so see in the main method print 5, okay, there is a print method you have declared, and here is SOP. So print, so print and int num. Okay, and here I'm printing num, and then calling print 2, which is also taking the num. Print 2 int num, SOP num, and calling print 3, which is taking the num. Okay, similarly, now I'll tell you these are the different methods. What is the change in that? Are they not similar? Argument also same, one argument, data type also same, inside function body also same. So are they different identical different functions, or a same? Or why can't we make it as a one function? If all the function body is same, argument is same, just a name is different, then why can't I'm just taking the space and creating different functions? Why can't I'll call myself digest this method. Now I can easily, damn sure, like now you can easily digest, because the base has got a clear, because it seems like they are calling itself only, because everything is same. See, this is the example. Now you have taken the ball and you have reached to A1 place. A1, another person came which is similar to you, and the body is same, it's similar, the face also same, it's identical to you. You both are the same face. This person also looking as the same, like face is same, everything is same, just a name is different. You are Y, suppose your name is N1 and his name is N2. So you two are the same person only, just a name is different. So it seems like you are not giving the ball to another person, you are giving the ball to you are giving ball to you only. You are giving ball to you only. You are calling you only. You are calling you only. You are calling you only. Okay. You are calling you only. You are calling you. Okay, with another name. Then you are calling you with another name. Till my task is not completed. Till I get the response. This is a recursion. Okay. So now suppose this is the what you have done. Very good. Now if I tell you this concept, now you're thinking, okay, that's a great idea. In the main method, print 5. Okay, so print int num, it is printing SOP num. And if you are calling again print with num, so print 5, it enter here, printed SOP print 5, it again go, and it again, like initially you are printing print 2, another function. So consider that, see, recursion is just a thinking. Okay, print 5 times, fine. So just you don't have to show it, but you need to think it. Okay, 5 times. So let's create in the mind, let's create 5 function. One function is calling another is calling third is calling fourth is calling 5. But here you very well know that all functions are just same. So okay, one function, see, I'm doing this in this way only. That is why I'll get a easily output, and I can code anything in recursion. That okay, it's not a recursion. It's just like we are calling 5 functions. We are calling 5 methods. It's not a recursion. Consider it in the mind. It's not a recursion. 5 methods. Okay, one is calling another is calling another is calling another. Fine. But here you just write, okay, print is calling print only. Now print is calling print. Okay, then that print is calling that print. That print is calling that print, because we know that all the functions are identical. So why we will write another function? Why can't we'll write the print only? So function will call function SOP 1 time printed, then 2 times, then 3 times, then 4 times, then 5 times. Okay, so here when print calls, it enter printed 5, then it calls print again. Seems like, see, when the person hand over the ball to P2, okay, so it looks like, okay, it is same identical person only. So why I will call myself and complete the task till A2, then again call myself. See, this person is calling another friend. See, the example is relating, how much the example is relating. Okay, so this is way it seems like it is calling itself only. So why will make it official? Here it seems like, but in actual it is why can't I make the official? Why I'm calling print 2? Let's call print only. And so it print 5, it again call print, again call the same function, again enter with the value 5, again call 5, again call 5, again call 5. Now you will be asked me that, okay, where it will stop? Where it will stop? There is another, see, this is one point of recursion. Another point is base case. Base case is the stopping point of recursion, like for loop I equals 1, I less than 5. Inside it, print statement. Okay, and when I reaches to 5, stop. Base case, if condition simple. What is the base case? Okay, so in the main method I'm calling print 5. I have done this, print int num sop num, again calling print num. So if I'll not include any base case, then it should run infinite loop, result in stack overflow. So before it I'll write that, okay, if the 5 got printed 5 times, the 5 got printed 5 times, return from here. Okay, now the stack come into picture. Please please be focused. Stack, here is a stack, and the stack property is first in last out, first in last out, first in last out. Okay, this is the function, and that's why I have introduced the name stack. Why? Because when the message has not been received, that yeah, ball has been reached, this person, the starting person, is in the stack and should be the person will go last. See, this is the person that A4 will free at the first. Okay, the person you have given the ball to A1, A2, A3, A4, A5, but you are still in the stack because you are in the tense mode. Okay, ball has been reached or not. Once the ball has been reached, when the message confirmed, then you will be the last person to go to the out of the stack. A stack is the memory where when function call start, it should came in this, it should take place in the stack. You can tell when you call print. Okay, so let me tell you. Yeah, this is the stack. This is the example we have seen. When print is called a print method, when this start, yeah, so before it the main method. Okay, because definitely everything we write in the main method only. So the very first thing is main method. When the control come inside main method, it see that, okay, main has one function, print is the function, it calls the print function. When the control go inside the print, it come here with the value 5. It printed SOP. Inside the print, it is another method, print 2. Print is calling print 2. Control come inside print 2. So print 2. Now print 2 is calling print 3. Print 3 is calling print 4. Okay, and print 4 is calling print 5. Fine. If now if I return the condition, what I'm talking about, like base case, so okay, so yeah, where is that? Yeah, now before calling I have just in the function only, see here, here print, and then just here before SOP and this calling, here I'll write that if the 5 times print, whatever we'll write here, just over just means over I'll write the condition like any condition that if the 5 got printed 5 times, if the 5 got printed 5 times, return means return from there, no need to go forward. Okay, so main method initiated, this called print 5. Okay, so control go into the print method. Now in the print method it is calling print 2, print 2 is calling print 3, print 3 is calling print 4, print 4 is calling print 5, and again it is checking the condition. Now here in the console 5 got printed 5 times, you need to return from here, so he will now return. Now if he return, this method came outside, gone, free, p5 got free, then he will return print 5 is return, whatever he want to return, he'll just return p4. Okay, now he's returning p4, the print 5 is returning like similar thing, you can easily relate here. When the ball has been reached to p, he will return a message. Okay, anything can return int, a string, here it is message, fine. When the message got returned to at a4 is handle this message to a3. Now a4 got freed, that my job is over, I have handled to the ball to the p, and p given the message, I deliver the message to a3, my job is over. So the first person to free is the last in. This is the last person that came into the race and the first person to go out of the race. This is the first person to come into the race, first in should be the last to out. That is the same. See, this example is a great example. So p5 got returned to p4 and p5 got free out. Then p4, because p4 got a return value, that means p4 also return that value to p3, p4 free out. Okay, let me use a different pen. p4 out, then p4 return p3, p3 out, p3 returns the same thing to p2, p2 out, p2 returns same thing to p5. This print only p, so p out, and then p is returning to the main method, main also out. Program overs. This is the flow of program. When any function will call, when any function will initiate, then that function takes place in a stack and it will come out from the stack after it got executed completely. That function executing, it is calling another function, it is in a stack, it is calling another function. Now that function is returning. Okay, that function got returned, means that is over, go out. It is also returning, go out. Now it is also returning and this function over, go out, final, go out, program over. This is what the stack. And here we ends complete recursion parts by parts. Okay, so this is what the recursion is. I hope you get a clear-cut understanding. Fine, now let me go deep dive into a code, this basic code, and let me code it in Eclipse so that you'll get a clear-cut understanding. Plus we'll do debug, execute the code line by line. So the recursion, the most hardest topic, where what people say, and I'll make you the most easiest topic. See, recursion is a great topic, like you can solve the big problems in just minutes, because what you will get from recursion, reaching the taking the ball from A to B is the big problem. You have divided that problem into smaller steps. That is why many people will say that recursion is dividing the complex problem into a small easy problem. Taking the ball from A to B is complex, but taking the ball from A to A1 is easy. Okay, see, this example will help you throughout recursion. Okay, so this is what the recursion is. Wow. Okay, so now let me go to my Eclipse. Here is my Eclipse. Okay, so I'm building the Spring Boot project. Okay, and this is what actually I'm building my private chatting application using Spring Boot. I'm a master of Spring. Okay, so that is my expertise. Okay, save. So let me create a new project. Recursion. No. If you want to learn Spring, then please comment down. I'll think creating the videos. Okay, I built the bank application, many applications. Fine. Let me create the class com.recursion. Recursion. Okay, class is basics of rec. Fine. Now what the task I given you, call the method. The first approach, let code that. Like, I am calling the method, let's create 5 methods. So your task is, I have given you a task is, I want to print 5 times. I want to print 5 times. Great. Okay, fine. So int num equals 5. Okay. Print is a method and you are passing the num. Oh, I have not created the main method. Actually I'm coding in that Spring. Okay, so many confusion. Yeah, so this is what. Now let's create this method. Static. Okay, and void print int num. Okay, and it is printing the num. Inside it you will call another method print2, which is taking the same argument. Okay, again create the same method. Create the method print2. Okay, and then you will fine, again create the same method similar to it. Just name it as a print2. You're calling print3. You're calling the print4. Okay, now here you are returning stack. Let me debug. The best way to understand. Now let me run it. The control the control stops here. Debug means executing line by line. Control will stop here. Stack, where is my stack? This is stack. Initially main method called. Main is a method, so main is in the stack. Okay, see here, it is a red button, means still program is running. Fine. Now when it is calling the print method, it came inside the print. That means when print initiated, print also come in the stack. Okay, fine. Now let me use a debug everywhere. Okay, so that it will be easy. Here also, and then here also. Yeah. Now it will print SOP num. Next, see 5 got printed. Okay. The next is it is calling print2. Yet print has not been finished. It is calling print2. So it is still in the stack. It is calling print2. So now print2 has been, the function has been initiated. So the print2. Fine. Now this is calling print3. See, first SOP executed, second time 5 got printed, calling print3. Now when print3 got initiated, print3 also came here. Okay, print3 came here, SOP executed 3 times. Fine. Now print4, it is calling print4. It has not been executed completely. Before it is calling print4. So print4 executed and print4 came here, and then it got executed like 4 times SOP executed, and then from here it is returning. Now stop from here into return, that means okay. Now from here give the message back. Next, see, returns print3. Now this function got over. It got executed, function got over. That means this P4 came out of the stack. Okay, see the flow. Next, print3 also got out of the stack. Control came here. Next, print2 also got executed. That means came out of the stack. See here, focus here, it is still red. That means program is running. Okay, so control is here. So next, this also print also executed, came out of the stack. Control is here. Now you can see here. Next, this also came out of the stack. Program is over. Getting? I hope in this way no one will explain. Okay, now I want you to please comment down. Please comment down, that will motivates me. Please comment down that how you are feeling. Now what is recursion? See, these, now observe the body of this. Keep the name aside, print1, print2, print3, print4. The body taking the same argument data type is same, body SOP, then calling other function which is also same. So why I'm using another function? If suppose I wanna print 100 times, will I create 100 functions? No. Why can't we create the same? If all the functions are same, why can't we why I'll not call myself itself print? Okay, so it will call print, then printed num, again call print, again call print, again call print. So when I run it, you can see, I told you, right? Stack overflow, because the stack has been filled. Why stack overflow? Here is a stack. Okay, now print main method and print call. Now print is calling itself, again print, again print, again print, again print, again print, again print. A limit reached, where a stack got filled. Definitely. So stack got filled, stack got overflow, stack overflow error. Fine. So this is what stack overflow error. What is solution? Now the base case. I told you, base case. Like, what is the solution? The solution is, you want print to be, you want the number 5 to be printed 5 times. What is the solution? The solution is, if the number reaches 5, then stop it, return from there. Now how you will get to know? Pass in the argument, suppose initially 0. Int, it's a basic, okay. There are many examples, there are many things, there are many way you can do it. So you are passing a value, count value, which is initially at 0. Fine, which is initially at 0. if count value equals 5, return. You're calling print the same function. So here also what you need to do is count plus count. See here, it is a stack. Main method, main got called, print enters into it, print. Now initially count is 0. Okay, if count equals 5, count is 0. No, it will execute num, that is 5. It will again call itself with the value num and count, one count increment plus count. So now the count value is 1. Okay, count value is 1. 1 equals 5. No. Again print plus count. Now count value is 2. 2 is equals 5. No. Again print. So in this way, when count reaches 5, return from there, return from there, return from there, return from there, return, and then over. Okay, so using the stack diagram, it will be very easy to understand. See, let me just run it. See, now there is no stack overflow because you have added the base case. So base case is the another part. If the recursion is a body, base case is the important part to stop it. For loop, the condition I equals 0, I less than equals 5. So what is the less than equals base case? You need to add the base case so that you will, once you will achieve the target, return from there. The what do you need to return? Whatever you want to return. Suppose string. Okay, return the string. Okay, now see here. Let me draw the stack and let me just achieve it using debugging. Run as Java, no, debug as. Control will stop here and next. Count equals 5. See, initially count, we are passing the print with the count value 0. Count is 0. Count is not equals 5. Okay. Print. Then again calling the same method with the incremented value of count. See the count value 1. Count value 2. So in the same way, when count reaches to 5, okay, when count reaches to 5, so here, somewhere here, when count reaches to 5, it should return. Now it is returning. Consider, think like there is the 5 methods. Print. Now suppose here I reaches count equals 5. Return from here, return from here, return from here, return from here, and then it is returning here. In the same way, the methods from the stack is getting freed out. And then go to the main method, and then main method also stops. In the console, 5 times 5 got printed. Now I want my comment box to be get filled with your concern, whatever your concern is. If you will not get the concept, please feel free to comment down, but I want you to please comment down. Okay, so this is what the part 1 of my recursion video, crash course recursion video, part 1. The part 2 is tomorrow or day after tomorrow. Okay, and then we will see the and I guarantee at the end of part 2 you will be solving easy and medium problems, any medium problems. Okay, and the part 3 hard problems, ninja level, FAANG interview, Google and Facebook. See, after this you can easily be solve easy problems easily. Okay, and the Microsoft, Amazon are easiest problems. Google, Facebook, hard problems. Wait till part 2 and part 3. Okay, so this is what all about this video. I hope you enjoyed the video. If you enjoyed the video, then please comment down, like, share and subscribe. Thank you.